Hello everyone. This is the first video in the series of Edexcel video which we will be putting up. And this video is based on sampling and data collection. Now, this is based on the Edexcel syllabus, but anyone can watch these videos if they want any understanding of the statistics part of mathematics. Moreover, we are also initiating a course for Edexcel students just for PKR 10,000, in which we are going to provide them all the videos, including the content and worksheets, which will be checked by our expert teachers, and they will have 24/7 help line by the teachers available towards them. So if anyone wants further information for this course, they can WhatsApp us at the number which is coming on the screen, or they can email us at our email address, and we are going to address the queries. However, we are going to post one video every day regarding our statistics Edexcel syllabus, which will help our students of Edexcel to gauge and have their revision for their upcoming exams. So let's start. So our today's topic is sampling and data collection. And as the name suggests, we are just going to see the basics related to how we can choose something from the population, some data from the population, why we need to do that, and how we can actually collect data. So let's move forward with our content. Okay, so we will start first. We need to explore the types of data we have. So we are starting with qualitative data, right? So we have two kinds of data. One is qualitative and the other one is quantitative. Now, qualitative data is basically data which does not have numbers. For example, the color of eye, it does not have number. It can be blue, it can be brown, right? It does not have number. The color of a teacher's car. These are examples of qualitative data. Quantitative data, on the other hand, would be something which can be counted or it can be measured, right? For instance, the height of the student or the number of students present in a class. These are all measures of quantitative data. So there are two types of data, qualitative and quantitative. And in quantitative data, we have further distinctions in discrete and continuous. So discrete data is a data which can be counted in clear steps or which occurs in clear steps, right? It can only take certain specific values. For example, the number of students in the class. Now, the number of students in the class are in whole number, 1, 2, 3, 4. It cannot be 1.23 or 1.5, right? So it is occurring in clear steps of whole numbers. That is what we define as discrete data. Whereas on the other hand, continuous data is the quantitative data, which has to be measured in a continuation form. There are no clear steps defined. For example, the weight of a student or the height of a student, it can take any value within the range, right? So in that case, it's better to define a range, because maybe someone's weight would be 48.7164 kilograms. Now that is difficult to measure, right? You cannot give it a proper value. So 45 to 50, giving a range would be, a better idea in cases like these, right? You would want to give ranges. Now, here there is an example of age, and with that example, I'll explain you the distinction between discrete and continuous, so it will become clear, right? Because it actually depends on the context of the question which you will get. On that, it will decide whether it is a discrete data or a continuous data. Now, if you're saying how many years old a person is, that is, discrete, because either a person is 1 year old, 2 year old, 3 year old, 4 year, it is occurring in clear steps. Understood? Clear steps occurring, it's discrete, right? If you mean how long a person has been alive, now you need to talk in months and days even. So you can, and maybe in hours, minutes as well. So that is when you cannot give your answer as a definite 1 year, 2 year. You need to be like 1.67 years maybe. Okay. So in that case, age would become a continuous measure, right? So data Qualitative, quantitative, in quantitative, you have two measures, discrete and then continuous, right? So this was the basic of the types of data we have. Okay, now there are some terminologies which you need to know before we move forward, and one of them is population. Now, a population basically refers to a whole set of things for which you're interested in. For instance, if you want to know that how many students in the whole world like mathematics. So all the students in the whole world, they are your population. They are your data of interest. You're interested in knowing about them, something about them. And what are you interested in knowing? Their liking towards mathematics. So that is the whole set of data, right? For example, here they've given an example as well. If a vet wanted to know how long a typical French bulldog slept for in a day, then the population would be all the French bulldogs in the world. But now it's not really possible. It's not convenient. It is costly. It is time consuming to test maybe all the bulldogs, or in our case, to test all the students, right? You cannot go and ask all the students. It's not convenient and it is costly. So in that case, you need to take out samples, right? And we will talk about this further. So a sample is actually a subset of the population. It is a representation of a population for which the data is collected. So the vet, if we continue with the vet example, we would say that the vet might take a sample of French bulldogs from different cities. Why from different cities? Because the data has to be represented, right? And then that vet can, basically record how long they sleep in a day, and that can represent the population. Okay? Now, we will look at the next thing, and then we'll come back to this concept in much more detail. A sampling frame is a list of all members of the population. This is very easy. A list of, for example, employees' name within a company. So a list of all the members of the population, because from the sampling frame, you will select your sample. So that is all the members of the population, right? Okay. Now, the last two terminologies are important, and that will actually help you make your concept. Okay. A population parameter is a numerical value which describes the characteristic of a population, right? So, for example, a population parameter is something you're interested in knowing. The mean height of all 16-year-olds in the UK. If you want to know that, that becomes your population parameter. That is something you want to know about your population, right? Any numerical value. Let's make a case in our thinking. Let's say we are a manager of a factory and we want to know about the mean lifetime of a bulb which is being produced in the factory, right? So the population parameter in this case would be the mean lifetime of all the bulbs in the factory which are being produced in the factory. However, it is not possible for us to test all the bulbs. We already discussed why, because it is costly, it is time consuming, and it will lead to the destruction of all our bulb units. What are we going to sell then? If we use all of the bulb units to test, we won't be able to sell any. We won't be able to do business. So that is not the purpose. So they would destroy, and hence they would be of no use. Hence, you cannot actually find the population parameter by testing the whole population. That's not possible. That's ideal, but that's not possible. So you use a sample statistic value, and that value is used from the data from the sample, right? You pick out a sample of bulbs, you test those bulbs, and whatever their mean lifetime is, you say that this is the sample statistic, the mean of the sample bulbs, right? And this is the best estimate of the population parameter. And in future chapters and, hypothesis testing and all these chapters, we will talk about this more. But this is the major concept of this, okay? So let's move forward, right? Okay. So here we can see population and sample. What's the difference? We can't test the whole population, so we pick out a few objects, few units from the population, and they act as a sample All of these people will be the part of the sampling frame, right? But only 3 of them become the part of the sample because they're selected. Okay. Now, how are the different ways of sampling? We will explore them further, right? Now, what is the difference between a census and a sample, right? Let's look at that. Now, we right now talked about population parameter, right? When we are using all the units of the population, and that actually describes, the characteristics of the population. Basically, census is when you are testing all the members of the population, all the bulbs, all the students in the UK. You are looking at everything. Government in England does a national census every 10 years to collect data about every person living in England at that time. Now, the main advantage of a census is that full accurate result. There is no room for inaccuracy or no estimation. Obviously, because you're testing the whole population. But the disadvantage is, as we discussed, it is time consuming, it is expensive, it can destroy or use up all the members of population. In the case of bulbs, we saw that. Imagine a company testing every single firework, right? Or imagine a manager testing every single bulb. That would be the same kind of example. So in that case, sampling comes in action. That is when you're collecting data from a subset of the population. And the advantage of sampling, it is quicker and it is cheaper than a census, and it leads to less data, right? Which is needing to be analyzed. But the main disadvantage would be it might not represent the population accurately. It is quite possible that you have selected all the units which are an overestimation, or maybe all the units which are an underestimation. Okay, so then it would not be representative for the population, or it could introduce bias. While selecting the sample, there has been some kind of a bias. Maybe the person who was selecting was more inclined towards selecting men, or was more inclined towards selecting women, or had certain thing in the mind through which he or she based his selection process. So all these things matter and can cause bias, right? Now we are going to look at some different sampling techniques which are a part of the statistics syllabus in most cases, and definitely in Edexcel. Okay, so there is simple random sampling. This is very easy. You have the whole population in front of you. If a sample of size is taken, every group or every member has the equal probability. Randomly, anyone from the population can be selected. Okay? Randomly selecting n different number using a random number generator or a form of lottery. For example, you're putting chits inside a box and you pick out chits. Or simply, if you do not want to do that, you can simply use tools on your computer to randomly generate numbers. Assign every unit a number and you can randomly generate numbers using Excel or any other application, right? And then there is systematic sampling. You are basically choosing members of a population at regular interval using a list. You've again assigned numbers to everyone, but this time you've, for example, decided you're going to choose at regular intervals. Number 3 is going to be chosen, then number 6, then number 9, then number 12. So you're skipping 2 people and choosing the other ones, right? So for this, how will we get to know the size of the interval? To carry out this out, you would calculate the size of the interval. And how do you find the size of the interval? That is size of population upon size of sample, right? That is how you get the k value. So you choose a starting point between that 1 and k value, and then you choose the next member after the first, right? So I'll give you an example about this. Let's say we have 10 people in a population and we need to select 50% of the population as the sample. That means 5 people as the sample. So 10 upon 5, right? In this case, it will be 2. Now, since it's set between 1 and the kth number, you can select 1 in this case because 2 is your k, right? So we start with 1. And then our interval comes at the next after two people, because our k is, after one person to the next second person, because our k is 2. So 1, and then 2, 3. So we select the third person as well. 4, 5. Fifth person is in. Seventh is in. And then ninth is. So we have 5 people like this. 1, 3, 5, 7, 9. Understood? And then we have stratified sampling. Now, stratified sampling is basically the population is divided into groups, disjoint groups. Disjoint groups means that one person has to be in one group. That one person cannot be in two groups. One person, one unit of the population has to be in one, right? So those groups are called strata. And then random sample is taken from each. That is strata, right? So for instance, if we had bulbs, we can take bulbs which were produced today, bulbs which were produced last week, bulbs which were produced older than last week, but newer than last month, right? So we made stratas, and then we can, select samples. Now, in this case of sampling, we will discuss in details the advantages and disadvantages of all these methods. But in this case of sampling, you're actually thinking from your mind. You're trying to get all possible options in your sampling so that the problems in the sampling are reduced, and you can actually test each and every time, right? So the proportion of a stratum that is sampled is equal to the proportion of the population that belong to that stratum. We're going to do a question on this as later on. So the number of members sampled from a stratum, that would be size of sample upon size of population into number of members in this stratum, right? So we're going to look at an example of this later, and then you're going to understand this better. Okay. Then we come towards quota sampling. Quota sampling is simply if the population is split into groups, similarly like stratified sampling. And then the members of the population, they're selected until each quota is filled. So there are quota. For instance, if a member does not want to be included, then obviously you would include the other member. The members do not have to be selected randomly. There's no random selection in this. There is a quota involved, right? And members of the population are selected until each quota is filled. So there would be a quota. Okay, you need to have in your sample, you need to have, let's say, out of 10 people in the sample, you need to have 6 females. A quota is set. So you need to take 6 females. You split them into groups, and then you need to take 6 females. Okay. Opportunity convenience sample. You simply take the people who are conveniently, or the units which are conveniently available to you, right? Who are fitting the criteria and they are readily available. That is opportunity sample. Now we will talk about when should each sampling technique be used or avoided. And this part is really important because obviously no one is going to ask you in your exam what is quota sampling or what is convenience sampling. They might, but more likely you're going to get a question like, Ali is doing this experiment, and then he wants to, he is using, let's say, convenience sampling. And do you think this is the best kind of sampling that Ali should use in this case? And if not, suggest another type. So we want to look at that why should, and when, rather than why, when should each sampling technique should be used or avoided, in what circumstances. So you can link the circumstances with the experiment and you can then decide accordingly, right? So that would help you with these kind of questions, the theory questions in your exam. So when should each sampling technique be used or avoided? Now, simple random sampling, which we talked about, when you want simply a random sample, you want to avoid bias. Now, that is very useful when you have a small population or when you want a small sample. Children in a class. The population is small, you want a small sample. It should not be used if it is not possible to number or list all the members of the population. Like, for example, if you cannot number them, this method cannot be used because then it would no more be random. Think about the fish in lake, right? Fish in lake. You're not able to number all of them. How can you randomly select? Right? Because until you don't number, you're not randomly select. Right? We come towards systematic sampling, right? You want a random sample on an interval basis. So this should be used when you want a random sample basically from a larger population. Smaller population, you look at simple random sampling. So for a larger population, you look at systematic sampling. So it is useful when there is a natural order, list of names, all of them are sorted on there, right? In order for the sample to be random, the sampling frame needs to be random. So the people should be randomly, if it is a list of people, it should be random. This cannot be used if it is not possible to, again, number or list all the members, like the fish in a lake or penguins in a tank. Okay. Then we look at stratified sampling. Now, stratified sampling should be used when the population can be split into groups. Because in stratified sampling, we are actually dividing the population into groups, where the members within a group, they should have some kind of a common characteristic. Like I told you in the case of a bulb, new bulbs, let's say 1 to 7 day old bulbs, 8 to 30 day old bulbs, right? So they should have some kind of a common characteristic. So it is useful when there are very different groups of members within a population. Then you would want people from all the groups or the units from all the groups. The sample will be representative of the population. That is another advantage. The members selected from each stratum are chosen randomly. They should be chosen randomly. Now, they sometimes in the exam question even list down the whole process, and they can say that, it was not random. So you need to pick out and tell, no, it should be random. This cannot be used if the population cannot be split into groups. Quite simple. If you're not, and disjoint groups, very important. If they're overlapping, again, no purpose. Quota sampling. This should be used when a small sample is needed to be representative of the whole population structure. So you're choosing a very, very small sample, but that small sample should be representative. So then you need to start setting quotas. So when you're, collecting data by asking people who walk past you in a public place, when a sampling frame is not available. So in this case, when a sampling frame is not available, when you do not exactly know about all the units of your population, then you should go for quota sampling. But this technique, this can introduce bias. Some members of the population, they might choose not to be included in the sample. Then we come towards opportunity or convenience sampling, right? This should be used when a sample is needed quickly. You need to quickly do the experiment. You're late. You just have to submit your deliverable tomorrow to your teacher, and you haven't done your work. Then you would obviously go for convenience sample. So when but in real terms, in statistics terms, this should be only used when a list of the population, again, your sampling frame is not available, and this won't be representative. You should know, and then you should mention this limitation that my sample is not representative of the population structure, right? Okay, main criticism of sampling, we just had a discussion into this. There can be a bias involved. Okay, and if you want to remove that bias, you should apply proper techniques of sampling. We just discussed the techniques. It should be random, right? Most sampling techniques can be improved. If you take a larger sample, always increasing the sample size would help. Sample only gives information about those members, obviously the members who are being selected, and then we assume that that is the best estimate towards the population, right? So, but obviously, each time you take a new sample, you would lead to a new conclusion. So these are some of the points to criticize sampling techniques, right? Now we are going to do an example, as I told you previously. And with this, we're going to end our video. Mike is a biologist studying mice in an open enclosure. He has access to approximately 540 field mice and 260 harvest mice. Now, this part is your population. This is your population, right? 540 field mice and 260 harvest mice. This is what Mike has. Mike wants to sample 10 mice, and he wants the proportion of the two types of mice in his sample to reflect their respective proportions of the population. Right? Calculate the number of field mice and harvest mice that Mike should include in his sample. Now, if you see, there are groups, there are disjoint groups, and you know random sampling cannot work over here. You know there is no, basically there are no intervals which can be formed. You cannot assign numbers to mice, right? So this is stratified sampling. This is how you identify. You can simply see there are disjoint groups and you can simply tell this is stratified. Now you need to calculate the number of field mice and harvest mice that Mike should include in a sample. We have looked at this formula, but let's see how we can actually use it. Now Mike wants to sample 10 mice, right? Only 10 mice. And we want to see the whole population actually is 540 plus 260. That is 800, right? So 800 and only a sample of 10 in total. Now, field mice are only 540. So let's see how many field mice should Mike actually select. So, right? And then we have 54 divided by 8, right? So that would give you some answer in decimals maybe, right? It would be 6 point something, right? But you need to give them a definite answer, so you should just round it off to 7. Given that Mike does not have a list of all mice, yeah, we just had to find field mice and harvest mice also. Okay, so 10 upon 800 into 260. That gives you 28 upon 8. So 24 upon 8 is 3. So let's just round this off to 3. So you have 3 harvest mice. I might have done a plus 1 minus 1 mistake because I'm not using a calculator. You rounded off to the nearest value, right? Given that Mike does not have a list of all mice, state the name of this sampling method. You do not have a list of, so you do not have a sampling frame, right? You're using other methods to do this, right? And then you cannot even use stratified sampling because you do not have a list of all the mice in the enclosure, right? So quota sampling, any sampling you wouldn't do. Mike would simply want to do convenience sampling, right? Suggest one way in which Mike could improve his sampling method. And we just discussed how you can improve sampling methods. You can simply increase your sample size, right? That is the way you can increase sampling method. So I hope you have understood this whole topic. And inshallah, we are going to come up with new videos and we are going to do the next topic. And till then, I would like to mention again that we have our complete course in which we have worksheets, in which we have 24/7 help, in which we have online sessions, in which we have past paper sessions, and that is going to be very helpful in complementing with these videos which we are already posting. So we hope you're going to subscribe to that soon as well. Thank you. Bye.